Hello everyone. In this video, we will be discussing some of the chemical reactions of aromatic hydrocarbons. Now, the amines are characterized more generally by electrophilic substitution reaction, and however, under special conditions, they can also undergo addition reactions and oxidation reactions. Now, let's check out the addition reactions first. Addition reactions. Now, if we check out the addition reactions under vigorous condition, means under extreme or under controlled or vigorous conditions, that is vigorous condition means at high temperature or at high temperature pressure in the presence of nickel or palladium catalyst, hydrogenation of benzene takes place. Okay, now the first addition reaction is hydrogenation, means addition of hydrogen. Now this is our benzene ring at high temperature and pressure at very vigorous conditions. It reacts with nickel or palladium and undergo hydrogenation at high temperature and pressure on heating to give all the pi bond breaks up to give our cyclohexane. Now the second is halogenation reaction or halogenation or chlorination. Chlorination generally takes place. Chlorination. Now this is our benzene ring. Under ultraviolet light, 3 molecules of chlorine atoms will be 3 molecules of chlorine atoms under UV light at 500 Kelvin. 3 molecules of chlorine adds up the benzene ring to produce benzene hexachloride. Okay, the 6 1 Cl. This would be known as all the 1, 2, 3, 4. Here also will be 4, 5, and 6. All the 6 positions are occupied by the chlorine atom. Therefore, known as 1, 2, 3, 4, 5, 6 cyclohexachloride. Since the aromaticity, that is the bonding, the pi bonds has disappeared, therefore the compound would lose its aromaticity, and this would be named as 1, 2, 3, 4, 5, 6 cyclohexa. This would be known as cyclohexachloride, or it is known as gammazen, or this is also known as gammazen. Now, these are the 2 addition reactions that occurs under vigorous conditions for the chemical reactions of aromatic hydrocarbons. Now, let's check out the electrophilic substitution reaction of amines. Now, even an electrophilic substitution reaction, electrophilic substitution reaction. Let's check out the first electrophilic substitution. The first one is halogenation, means addition of halogens. Now, if we take this is our benzene ring, we know that there is an H here. All the carbon atom says H here. Now we need halogens. Under AlX3, it will begin. One of the other will be halogenated with the release of HX. Now, what are the reagents in this process? The reagents generally, if you use Br as the halogen, then the reagent here would be the catalyst FeBr3, and if we use we can use Br plus AlBr3 also, and then Fe plus Br2 also can be used. Now, another type for chlorination can be Cl2 plus FeCl2 can be used, or Cl2 plus AlCl3 can be used, or Cl2 plus Fe can be used as a different reagents. Now, let's check what happens when Chlorination means addition of chlorination. Chlorine takes place. These are benzene ring. This Cl, Cl. Now, if this bonding electron goes here, this will become, along with the 2 it leaves, this will become Cl plus, and then this will be Cl minus. Now, in the reagent we have AlCl3. Now, this Cl minus, since this is a Lewis acid, Cl minus comes and bonds with this AlCl3, and AlCl4 minus would be formed in the solution mixture. Now this Cl plus acts as an electrophile. Now if this pi bond breaks and then adds up here, we would be getting a positive. If it adds up here, then we'd be getting a positive sign here, a negative sign. Therefore, this electrophile attacks the negative part of the benzene ring, and then we would be getting here. One pi bond is here, one pi bond is already, a positive sign would be formed, and then our Cl would be attached here. Now, this should also be aromatic, therefore we know that in every chemical reactions, we know that there is an hydrogen atom in this place, therefore there is loss of this hydrogen as a proton. It goes out as H plus, and then this bond along with 2 bonding electron comes to form a pi bond here with removal of H plus, and then we'd be getting here the pi bond, a double bond would be formed here, and then we'd be getting here this would be known as our chlorobenzene, and in this way chlorination reaction takes place. Now let's check out Friedel-Crafts acylation and alkylation reaction. Now let's check out Friedel-Crafts acylation and alkylation reaction. Now the first acyl group, the addition of an acyl group to the halogen. Now in acyl group, the reagents used are CH, Cl is plus, AlCl3 is used. Now this Cl minus, along with the 2 bonding electron, it goes here, and then the Cl minus comes and adds up to this form. Therefore we'd be getting AlCl4 minus plus CH3, C double bond there, O oxygen, and then since the bonding electron has left along with the chlorine atom, carbon would obtain a positive charge, and this would act as our electrophile. Now we have our benzene ring here. The benzene ring here is here. Now if this bonding electrons, but the pi bond breaks and it's up to this carbon atom, then we'd be getting here a negative charge would be for a positive charge. Therefore our electrophile is CH3, C double bond oxygen, and then positive charge. The positive charge comes and this comes and attacks here, and therefore we would be getting here, it has bonded to a carbon, C double bond O, CH3, and a positive charge would be formed in this process. Now in this type of reactions, the same mechanism takes place. We know that there is an H here. Now a positive sign there, along with the 2 bonding electron, the bond breaks here, and then there is removal of minus H plus. Hydrogen is released as a proton, and therefore hydrogen is released as a proton. Therefore we'd be getting here our product as a pi bond would be formed here, C double bond oxygen, and then CH3, and the addition of the acyl group to the benzene ring is over, and this is known as Friedel-Crafts acylation reaction. There is removal of HCl, the H plus goes and bonds up with one of them. We know that we have the AlCl4, one Cl minus was released, and then it went and add up with AlCl3. Therefore the H plus that was released in this case goes and adds up to the Cl minus, and then there will be removal of HCl. Now what is Friedel-Crafts alkylation? Alkylation reaction means addition of alkyl groups to the benzene ring. Now, in our fiddle graphs, this is our benzene ring with an alkyl chloride in the presence of anhydrous aluminium chloride AlCl3. The benzene ring, there is addition of alkyl group to the benzene ring with the removal of HCl. Now, let's check the mechanism here. We have CH3 here, Cl. Now, along with the two bonding electrons, if it leaves away, then we'd be getting here CH3 plus an electrophile would be formed, and then Cl minus would be here. Now, if this is our benzene ring, the same mechanism happens. CH3 plus, if this goes here, then this comes and bonds up with this part, and then we'd be getting here a positive sign would be formed here because the pi bond broke and went up and add up to this carbon atom, and then our CH3 would be attached here. Now we know that there is a hydrogen here. Now this hydrogen is released as a proton along with the two bonding electron. It comes and adds up here. There's removal of H plus, and then we'd be getting here our substituted benzene ring, and there this H plus goes and adds up with the Cl minus, and along with this we'll be getting HCl. So therefore this is the Fiedel-Crafts acylation, addition of acyl group to the benzene ring, and Fiedel-Crafts alkylation reaction means addition of alkyl group. This is the alkyl group to the benzene ring. Now let's check the third chemical reaction of benzene, that is nitration reaction. The mechanism occurs in the same way as that took place for Fiedel-Crafts alkylation, acylation reaction, and halogenation reaction. In nitration, benzene reacts with concentrated nitric acid along with concentrated sulfuric acid at 323 to 333 Kelvin to form here addition of NO2. This is known as nitrobenzene. Nitrobenzene is formed in this process along with the removal of water. Now how does this mechanism take place? Now the sulfuric acid can be written in this form, H2SO4. Now along with the bonding electron, if this goes here, there's removal of hydrogen as a proton here. Now this is our nitric acid, HNO3 nitric acid. Now the H plus comes and joins up here, and then therefore we'd be getting HO. The one H came and bond with H, and then this would be NO2. Therefore a positive sign would be formed here. Now since it has to fulfill the deficiency, along with the two bonding electron, it comes and adds up the oxygen atom. Therefore there will be NO2 would become positive, and this would act as our electrophile, and then there will be removal of water would be removed in this case, and we'd be getting water here as that was formed in the final product here. Now let's check how the electrophile attack the benzene ring. The mechanism is all the same. NO2 plus comes, if this goes here, then NO2 plus comes and attacks this carbon atom, and therefore we'd be getting a positive sign here, and our NO2 would be attached here. We know that there is an hydrogen here. Hydrogen is released as a proton, along with the two it moves there, and then we'd be getting here pi bond would be formed in this process, and to our nitrobenzene would be obtained in this process. Now let's check the fourth chemical reaction, that is sulfonation. Now what is sulfonation reaction? Sulfonation reaction, it reacts with sulfuric acid. The benzene ring reacts with concentrated sulfuric acid. On heating, benzene will be getting benzene sulfonic acid along with the removal of water. Therefore now the same mechanism takes place. HOSO3H, this goes here, therefore there will be release of the proton. Now it reacts with two molecules of sulfuric acid. Therefore, another molecule of sulfuric acid is here. Now, this comes and attacks here. Therefore, we'll be getting HOH SO3H. A positive sign would be formed here. Therefore, to fulfill the deficiency, along with the two bonding electron, it goes to the oxygen atom, and then SO3H would have a positive sign here. And therefore, this acts as the electrophile and attacks the benzene ring in the same mechanism as in this case. Now, let me write the mechanism here. This is our benzene ring. The SO3H, our sulfonic acid, is here. This goes, it comes and attack here. Then we'll be getting here our SO3H. A positive sign would be forming. We know that there's a carbon is always tetravalent, therefore there are hydrogen here. The bonding electron comes, hydrogen is released as a proton, and we'll be getting here bipond would be formed, and we'll be getting SO3H. This is known as benzene sulfonic acid. Therefore, these are the electrophilic substitution reactions of benzene, and where nitration, sulfonation, Friedel-Crafts alkylation, acylation reaction took place, and then benzene ring also undergo addition reaction, that is hydrogenation and chlorination reactions. Therefore, this is the last video, the end video for our unit, that is hydrocarbons.